All right, let's talk about a galaxy that's got it's got a bit of an identity crisis. Meet Messier 86. This thing is basically breaking one of the biggest rules in the entire cosmos, so you're going to want to stick around for this one.
So, here's the big mystery right off the bat. We live in a universe where pretty much everything is flying away from everything else, right? But not M86. Nope. This galaxy is one of the very, very few distant ones that's actually hurtling towards us. How is that even possible?
And here it is, our cosmic rule breaker. This is Messier 86, hanging out in the Virgo cluster, which is, about 52 million light-years from home. Now, if you just look at it, you might think, okay, it's a giant elliptical galaxy. Kind of looks like a big fuzzy ball of old stars. What's the big deal? But trust me, its looks are seriously deceiving.
Okay, so to really get why this is so nuts, you got to remember one of the absolute cornerstones of cosmology. The universe is expanding. Everything's moving away from everything else. This stretches out the light from distant galaxies, shifting it toward the red end of the spectrum. We call that redshift. So given how far away M86 is, it should be screaming redshift, but it's not. Its light is blue shifted, and that means one thing, it's coming our way.
So think about this for a second. To fight against the entire expansion of the universe and still be moving towards us, M86 has to be moving at an absolutely insane speed through its own galactic neighborhood. We are talking more than 1,500 kilometers per second. That is it's screaming through the Virgo cluster. But as wild as that is, believe it or not, its shape is even stranger.
And that brings us to the next piece of this puzzle. It turns out its weird motion is totally connected to its even weirder shape. Okay, quick thought experiment. Picture any spinning, flattish object. A frisbee, a dinner plate, even a pizza dough in the air. How does it spin? It always spins around its shortest axis, right? It's just physics. It's the most stable way for things to spin.
Well, get this. M86 apparently didn't get the memo. It breaks this rule too. It's kind of flattened, but it rotates around its longest axis. Imagine a cigar just rolling end over end through space. For a galaxy that's supposed to be like a disk, that kind of spin should be completely impossible. So what in the world is its actual shape?
And that's the tell. M86 isn't a simple, flattened disk at all. It's something astronomers call a triaxial ellipsoid, which sounds complicated, but there's a much better way to think about it. It's shaped like a kiwi, a giant cosmic kiwi fruit. It's got a long axis, a middle one, and a short one. And it just so happens that if your gravity field is shaped like a kiwi, your stars can actually orbit around that long axis. So the weird shape, it perfectly explains the weird rotation.
All right, so we've got a kiwi-shaped galaxy. But why is it moving so dang fast? Well, the answer lies in the neighborhood it's tearing through.
Take a look at this. This is an X-ray image from the Chandra observatory, and it basically reveals the scene of the crime. That bright blob in the middle, that's M86. And that enormous plume streaming away from it, that's a trail of hot gas being violently torn right out of the galaxy. There's a name for this process. It's called ram pressure stripping. And that's actually pretty intuitive. You know how when you stick your hand out the window of a fast-moving car, you feel that powerful wind pushing against it? Well, imagine that, but on a galactic scale. M86 is plowing through this super hot, thin gas that fills the entire Virgo cluster. And that intergalactic wind is literally stripping M86's own gas right off of it. This little diagram here shows you exactly what's going on. You've got the external flow of that cluster gas, the wind, slamming into the galaxy. That creates this incredible pressure, and it blows the galaxy's internal gas clean out the back, leaving this long, trailing tail.
Okay, so we're talking about a tail of gas. But the sheer scale of this thing is mind-blowing. And get this, its very specific shape is the last clue we need to tie this whole M86 mystery together.
And I'm not exaggerating here. The scientists who studied this literally called it the longest ram pressure strip tail presently known. This isn't just some everyday occurrence. What we're looking at is a record-breaking cosmic event.
So how long is record-breaking? This tail stretches for at least 380,000 light-years. Okay, let that sink in. That's more than 3 times the diameter of our entire Milky Way. It's just an impossibly long scar across the sky, marking this galaxy's violent trip.
But wait, there's one last twist in the story. Check out this model. The white line shows the path the galaxy is taking, right? But look at the gas tail. It's not trailing straight behind. It's kind of pushed off to the side. So what's going on with that?
And this is where everything clicks. It's the Kiwi. It all comes back to the Kiwi shape. See, as that gas gets stripped away, the galaxy's gravity is still tugging on it. But because the galaxy isn't a perfect sphere, it's this lopsided, irregular shape, its gravitational pull isn't perfectly centered. It actually yanks the tail off to the side. The weird shape is directly responsible for the weird tail. It all connects.
So we've kind of pieced together this wild, unfolding cosmic story. It explains so much about this really strange galaxy. But the story's not quite over.
Okay, so let's just run through the clues one more time. We have a galaxy hurtling towards us at supersonic speeds. It has this bizarre Kiwi shape that makes it tumble around its long axis. It's trailing the longest tail of stripped gas ever seen. And that very same unique shape is what's pushing that tail off to the side. See? Everything is connected.
And, just to make things even more interesting, scientists think there might be another chapter to this story. There's some evidence that M86 had a pretty nasty collision with a neighboring galaxy, maybe 100 million years ago. A sort of galactic hit and run that could have messed up its shape and knocked some of its gas loose, making it even easier for that ram pressure to strip it away.
So all of this leaves us with one last big question. M86 is being robbed of all the raw material it needs to make new stars. So as it keeps on plunging through the Virgo cluster, getting slowly dismantled piece by piece, what happens to it? What is the ultimate fate of this cosmic Kiwi? Well, all the signs point to it eventually becoming a red and dead galaxy. Its fires will fade, and all that'll be left is just the ghost of the incredible, strange galaxy it used to be.